On the 27th of April, 1900, I stood before the Royal Institution in London and told the world that physics had a problem. I had spent 50 years building the foundations of science. I had been knighted by the Queen. I was the most powerful voice in British physics. And I told them that the work of Ludwig Boltzmann was a cloud over physics, an unresolved problem, a doctrine that did not hold. My name is William Thomson. The world knows me as Lord Kelvin. I was born in Belfast in 1824, the son of a mathematics professor, and I entered the University of Glasgow at the age of 10. By 22, I was its professor of natural philosophy. In 1866, Queen Victoria knighted me for my work on the transatlantic telegraph cable, the first permanent cable to carry words across the Atlantic in seconds, when they had previously taken weeks by ship. I designed the absolute temperature scale that science still uses today. In 1892, I became the first scientist elevated to the British peerage. The world listened to me. That is the only thing you need to understand about me to understand what I did to Boltzmann. Ludwig Boltzmann was born in Vienna in 1844, 20 years after me. His father was a tax official who died of tuberculosis when Ludwig was 15. The boy was left to find his own way. He found it through mathematics. Those who knew Boltzmann in those early years described a large man, broad and round, always slightly disheveled, with thick glasses and an enormous beard that seemed to arrive in a room before he did. He played the piano. He laughed loudly. He loved hiking in the mountains above Vienna and would return sunburned and triumphant, already planning the next expedition. But under that warmth, there was something else. A darkness that came without warning, moods that plunged without reason and took days to lift. He joked about it, said it was because he had been born in the dying hours of a Mardi Gras ball, caught between celebration and ash. It was not a joke. He suffered, quietly and severely, for his entire life. He earned his doctorate in Vienna in 1866, at the age of 22. In 1869, he became professor of theoretical physics at the University of Graz, 25 years old, the youngest professor in the building. He arrived on the first day, smiling broadly, and immediately began talking about atoms, as though they were as self-evident as the chairs his students sat in. He was not performing. He was explaining something he believed the way most men believe in the ground beneath their feet. He believed the world was made of something no one had ever seen. Billions of invisible particles constantly moving, constantly colliding, and he believed he could prove they were real. In 1872, he published the proof. What he showed was this: if you accept that atoms exist, you can prove, mathematically, that heat will always flow from hot to cold, that the world tends toward disorder, not because someone decided it should, because of how invisible things behave when there are enough of them. He had found the reason behind one of the deepest laws in physics, and the reason was atoms. The question everything turned on was simple. Are atoms real? Not useful. Not convenient. Real. Actually existing. Actually moving. Actually responsible for everything we call heat and pressure and temperature. Perhaps you already sense the answer. But in 1872, the most powerful minds in European science did not agree. And what they did to Boltzmann because of that disagreement is why I am still thinking about him from my grave. The opposition came immediately, and it was powerful. Ernst Mach was the most influential philosopher of science in the German-speaking world. His position was simple and brutal. If you cannot observe something directly, it has no place in science. You cannot see an atom. Therefore, atoms are not science. Wilhelm Ostwald, the most respected chemist in Europe, agreed. Energy was the only real thing. Atoms were an unnecessary fiction. Neither of them could match Boltzmann's mathematics. So in September 1895, he decided to settle it in a room. The annual gathering of German-speaking scientists that year had scheduled special sessions on the question of atoms. Ostwald was there to defend his position. Boltzmann rose to answer. A young mathematician named Arnold Sommerfeld was watching from the audience. He later wrote that the fight resembled a bull against a matador. Ostwald was the fencer, elegant, technical, agile. Boltzmann was the bull, direct, massive, unstoppable. The bull won. Boltzmann dismantled Ostwald's mathematics step by step in front of the room. Sommerfeld wrote that every young scientist present sided with Boltzmann. It was obvious, he said. It could not have been more clear. Ostwald left and published written rebuttals in the journals. Mach continued in print. Nothing changed. Boltzmann returned to Vienna and kept working. He published. He lectured. He answered every rebuttal with a more precise version of the same argument. There is something both admirable and heartbreaking about a man who responds to being ignored by doing the work again, more carefully, as though the problem is only that he has not yet been clear enough, as though one more paper will be the one that settles it. Year after year, the same conclusion, the same silence from the people who mattered. Perhaps you have been in a room where you were completely right, and it made no difference, where the argument was settled, and the world did not follow. That is where Boltzmann lived, year after year, for 30 years. I was part of the world that did not follow. I did not deny that atoms existed, but I had serious doubts about Boltzmann's statistical method, about treating the physical world as a game of probability. In my 1900 lecture at the Royal Institution, I named his doctrine one of the two great unresolved clouds over physics. Not wrong exactly, but unproven. Perhaps you have been in that position too, where someone younger tells you something is true, and you understand the argument and still cannot bring yourself all the way to the end of it, where the weight of everything you have already built holds you back. That was where I stood, and I had the authority to make that hesitation matter in ways Boltzmann could not overcome. Boltzmann spent his final decade moving, Munich to Vienna to Leipzig, and back to Vienna again. Each city was partly an escape from the one before. In Leipzig, he was a colleague of Ostwald's. The arguments never stopped. He wrote in those years that he felt like a powerless individual struggling against the currents of the time. While in Leipzig, Boltzmann attempted suicide for the first time. He survived. He returned to Vienna. In those final years, he was given a new assignment alongside his physics work, teaching philosophy lectures open to the public. Something unexpected happened. The lectures filled immediately. Then they overflowed. Then the university had to move them to larger and larger rooms because there was no space for the people who wanted to hear him. Here was a man whose scientific peers had spent 30 years treating his work as unproven, drawing public audiences so large they could not be contained. He wrote to a friend that he lived in fear of suddenly losing his mind during a lecture, that the fear sat with him every time he stood at the podium. Boltzmann proved Kelvin wrong, and he died before anyone believed him. Hold that for a moment. More than 30 years. More than 30 years of papers, of lectures, of conference halls, of published rebuttals. More than 30 years of being the man who insisted the world was made of something invisible, and proving it mathematically, with a precision that his opponents could never quite match, and dying with the question still open. I had stood before the Royal Institution in 1900 and named his work a cloud over physics. I had the authority of 50 years and a title and a seat in the House of Lords. He had the mathematics. The mathematics was right. The title was louder. In the spring of 1906, the dean of his faculty wrote that Boltzmann was suffering from a serious form of neurasthenia, the word they used then for a mind that had been carrying too much for too long. He was ordered to resign his professorship. He was told to stop all scientific work. The one thing that had sustained him through the depressions, through the moves, through the conference halls and the rebuttals in the silence, he was told to put it down. He went on holiday with his family to the Bay of Duino, near Trieste. A quiet place, blue water, his wife and daughter with him. On the 5th of September, 1906, his wife and daughter went to swim. He was 62 years old. He left no note. His wife and daughter returned from the water to find him gone. He was buried in Vienna. On his tombstone, carved in stone, is the equation he spent his life defending. S equals K log W. The mathematical statement that the tendency of the world toward disorder is a consequence of how many ways invisible particles can arrange themselves. It is arguably the most important equation in the history of physics. 1 year before Boltzmann's death, in 1905, a 26-year-old patent clerk in Bern published a paper. Albert Einstein had been studying the strange jittering movement of tiny particles suspended in liquid. Pollen grains, dust. They lurched left and right with no pattern anyone could explain, and they had been doing so since the botanist Robert Brown first noticed them in 1827. Einstein showed this was not mysterious. It was exactly what you would expect if the liquid was made of atoms. Billions of invisible molecules hitting the suspended particle from every direction, occasionally harder from one side and sending it lurching. He gave a number. He said, "Measure how far these particles move, and you will know whether atoms are real." Boltzmann never saw what came next. 3 years after his death, the French physicist Jean Perrin completed the measurements Einstein had predicted. He counted. He calculated. He confirmed, with experimental precision, that atoms were real, that they moved exactly as Boltzmann had described, that more than 30 years of mathematics had been a precise description of how the world actually worked. Wilhelm Ostwald, the man who had stood across from Boltzmann in Lübeck in 1895 and published written rebuttals after losing, read Perrin's results and reversed his position publicly. He wrote that he was now satisfied, that the atomic hypothesis was no longer a hypothesis. Boltzmann had been dead for 3 years. I died on the 17th of December, 1907. I had continued working until 3 hours before the end. I was 83 years old. I had seen Einstein's paper and understood what it pointed toward. I was buried in Westminster Abbey beside Isaac Newton. I had lived long enough to suspect I had been wrong, not long enough to be certain, and I was, until the end, unable to say so plainly. That is perhaps the most honest thing I can tell you about myself. What I did not understand, what I failed to understand for 50 years, was that some things can only be seen by their consequences. That the jittering of a particle in water was the fingerprint of a billion invisible collisions. That absence from direct observation is not the same as absence. Boltzmann understood that. He understood it in 1872. He defended it for more than 30 years. Against Mach, against Ostwald, against me. He proved me wrong. The confirmation came in 1909, 3 years after his death, in a series of careful measurements by a French physicist who followed the path Einstein had marked. On the 27th of April, 1900, I stood before the Royal Institution and named the Maxwell-Boltzmann doctrine a cloud over physics. An unresolved problem. It was not a cloud. It was the answer. And somewhere in Vienna, in the central cemetery, on a stone engraved with an equation, the man who found it is buried. He did not live to hear anyone say so.